Okay, what we're going to do in this podcast is take a look at naming compounds and writing formulas for compounds. So we'll talk about ionic compounds, molecular compounds, and then we will talk about acids and bases. Let me get my pen. Okay, let's first take a look at metals versus nonmetals. So when you're looking at your periodic table, what we've got to do is differentiate between metals and nonmetals. So what we'll do is draw a line going down the periodic table stepwise from there to there to there to there to there to there. Most periodic tables already have this line present, but just in case you're looking at one that doesn't, I want to make sure we understand where that line is. Everything to the left of that line we're going to call a metal at this point. Now we'll talk about transition metals and metalloids a little bit later, but for what we're going to do, anything left of that line is what we're going to call a metal, and anything to the right of the line is a metal. So gallium would be a metal. Calcium would be a metal. Iron would be a metal. Chlorine would be a nonmetal. Phosphorus would be a nonmetal. Helium would be a nonmetal, etc. It's very, very important to understand the difference between metals and nonmetals. We also talked about in class how we find these charges on the periodic table, and we'll talk about how we do that again when we talk about bonding. But if you remember, in class we said everything in column 1 is plus 1, everything in column 2 is plus 2, everything in column 3 is plus 3. We skip the carbon column, and then minus 3, minus 2, and minus 1. So if the question was, what's the charge on calcium? Plus 2. What's the charge on gallium? Plus 3. What's the charge on chlorine? Minus 1, etc. We're not going to worry about the transitions at this point. We're only concerned about the elements in column 1, 2, 3, 5, 6, and 7. And if you remember, we might as well mention this, that the charge on everything in column 8 we're going to say is 0. So when we're writing these formulas, you want to have your periodic table handy so you can refer to the element on the periodic table and determine its charge quickly. Okay, let's take a look at ionic compounds. Okay, an ionic compound is a compound that's made up of a metal reacting with a nonmetal. And again, I'm not going to go into all the details I went into during class. I'm just going to give you the basics. So let's say we take calcium and it reacts with phosphorus. It's a three-step process to determine the formula of the compound. The first step is write the formula, or I should say write the symbol for the element. So calcium is Ca and phosphorus is P. The second step is to determine the charge of the element. So if we look back at our periodic table, calcium is plus 2 and phosphorus is minus 3. So going back to our problem, we said calcium is plus 2, and I always write it as 2 plus, and phosphorus is minus 3. And again, we want the overall charge of the compound when those two things react to be 0. So the trick we learned was you take that number, put it there, take that number, put it there. So the formula would be Ca3P2. When we go to name that compound, we name the first metal, calcium, or I should say the first element, which is a metal, calcium, and then we name the second element, but we drop the ending and then add IDE. So we would say calcium phosphide, IDE ending. All right, let's take a look at just a few more examples. Let me get another pen. Let's say we take aluminum and it reacts with nitrogen. Okay, write the symbols, aluminum, write the symbol, nitrogen. Aluminum's charge is 3 plus. Nitrogen's charge is 3 minus. So when we crisscross these two, the formula is going to be Al3N3. But remember, like what we said in class, when you have ionic compounds, we write them in the lowest whole number ratio. So Al3N3 would reduce to Aln. Since those subscripts are going to reduce to 1 and 1, we don't write the ones, they're implied. Let's take a look at one more. Let's take a look at lithium and oxygen. Again, metal and a nonmetal. Write the symbols. Lithium, O for oxygen. Charge on lithium is 1 plus. Charge on oxygen is 2 minus. That number goes there. That number goes there. So we would have Li2O. And again, if you had 2 lithiums, 2 times 1 plus would give you an overall charge of 2 plus for the lithiums. 1 oxygen at 2 minus would be 2 minus, so the overall charge would be 0. And that's what we want for ionic compounds. Okay, let's take a look at molecular compounds. Molecular compounds are ones where you have a nonmetal reacting with a nonmetal. This is where we use the prefixes, and the prefixes that we went over in class were mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So let's take the most common covalent compound, which would be CO2. Again, carbon is a nonmetal, oxygen is a nonmetal. You indicate the number of each element using the prefix. So since we have 1 carbon, we're going to, well, you would think it would be monocarbon. We've got 2 oxygens, so we know it's going to be dioxide. But again, the rule is when the first one is 1, we don't say mono, we simply name the element. So carbon dioxide. On the other hand, if we had CO, we would say carbon. Now the second one is 1, so we will say monoxide. So CO is going to be carbon monoxide. Let's take a look at just a few more examples. Let's say we have the compound, whoops, let me get a pen here. Let's say we have the compound N2O3. Again, nonmetal and nonmetal, so we're going to use our prefixes. We've got 2 nitrogens, so we're going to say dinitrogen. And then we've got 3 oxygens, so we'll say trioxide. Let's take a look at, let's say, N2O5. Again, we've got 2 nitrogens, so dinitrogen. And now we've got pent. Now the prefix is penta, and you would say oxide, but remember when we have the A and the O's butt up against each other, we would drop the A and we would say pentoxide. So dinitrogen pentoxide. So again, if we have ionics, a metal and a nonmetal, we do the crisscross with the charges, and we name the first one calcium and phosphorus. When we have covalence, that's 2 nonmetals, we use the prefixes to indicate the number of each element. Carbon monoxide, carbon dioxide, dinitrogen trioxide, dinitrogen pentoxide. We'll do another vodcast in a little bit to go over the other naming compounds.